Okay, yesterday we talked, kind of jumped out of turn, and we went to chapter 11, 4 and 11.5. Now we're going to be back in chapter 10 on 10.4, which we're going to talk about using the inscribed angles and polygons. Here you can see over here on your left, you got quite a bit of vocabulary. Again, that was one of the things I stressed to you about the beginning of this chapter. There's a lot of vocabulary when it comes to this. The first thing we're going to talk about is our inscribed angle. An inscribed angle is an angle whose vertex is on the circle and the sides are chords. So if you look down here, the vertex E is right there. It's on the circle as stated in the definition, and the sides are chords. For those of you guys who are still struggling with the vocabulary, that is a line that goes from one side of the circle to the other side. Okay. So angle AEC is an inscribed circle. Inscribed angle. Okay, with that, our next vocabulary word is the intercepted arc. Intercepted arc is the part of the circle, or arc of the circle, that lies inside the angle. Okay, so if this is my inscribed angle, the intercepted arc then in turn would be this arc AC. Okay, so let's take a look at that, because now we also have, in addition to that, we have this other angle ADC. What kind of angle is that? Remember, that's the angle coming out of the center of the circle. So ADC is a central angle. Okay. So with that being said, let's take a look at our example up here. I want to make one correction to the notes here a little bit. If you're using the notes, this should not necessarily be arc ABC, because if the arc measure here is 1/16, that's a minor arc. So all we need to know is that it is arc AC. Okay, that should be arc AC, not arc ABC. Okay, so arc ABC or AC, is 1/16. So if we know what arc AC is 1/16, okay, so this arc here is 1/16. What is angle measure ADC? If you remember from previous chapters or previous unit, that we know the central angle is equal to the arc measure, right? Okay, so that means ADC is also 1/16. Now, if you notice, and what you should remember is that basically, as this angle, if I was to pull D over to angle E, and I would just pull that back like a rubber band, your angle starts to get smaller, right? Okay, so as your angle gets smaller, how much further away is E from B? Well, if this from D to B is a radius, that means it's twice as far from E to B. So if it's twice as far from E to B and my angle is getting smaller as I get further away, I'm twice as small, or half the size. So what you're going to find out is that AEC is half of that 1/16, which is 58 degrees. So inscribed angles are equal to half of the intercepted arc. Something that you need to commit to memory is the inscribed angles are equal to half the intercepted arc. And that'll make your life a whole lot easier. So this angle right here, AEC, is equal to that 58 degrees. Okay, moving forward. With all that new knowledge that we just gained, let's looking at this diagram here. What is the angle of measure? What's the measure of angle F? right here. Okay, well, is this an inscribed circle? I'm sorry, inscribed angle, or is this a central angle? Well, because our vertex is on the circle and our legs of the angle are chords, it would be an inscribed angle. Since it's an inscribed angle, it is half of the intercepted angle, which is the intercepted angle is right here, which is given to us as 100. So since it's half of 100, angle F must measure 50 degrees. Okay? If we go backwards and we're given angle G here, or FGH, what is the measure of angle of arc FH? Well, is this angle a central or an inscribed? Well, your vertex is on the circle right here. Your two angle legs make a chords for the circle, so that would be an inscribed angle again. And if the inscribed angle is half of the arc, the intercepted arc, which FH is the intercepted arc, that means that the intercepted arc is 2 times the angle of the inscribed angle. So FH is going to be 2 times 35. Or 75 degrees. Excuse me, 70 degrees. Okay? Now, what about arc GH? I challenge you just for a second to pause the video and try to figure out what GH is. One of the things that you're going to notice that's challenging about this, if you're trying to do this on its own, there is no inscribed angle to take half of or to multiply by 2 in order to find GH. There's also no central angle to help us with GH. But if you look closely, the thing that you'll find if you've already come back from your pause is that this measure right here is equal to what? It's 180 degrees, right? It's a semicircle, and that is because GF is a diameter. So you know this whole thing is equal to 180 degrees. Well, we just figured out that FH, right here, is 70. So if this is 70, and the whole thing equals 180 degrees because it's a semicircle, that must mean that GH has to be 180 minus 70, or 110 degrees. Okay? Likewise, we'll go for finding arc JF. Now it should be easy because we just helped you with that one. So if this is my entire semicircle, I'm given 100 right here. That means the only part that's left is right here. And so then you end up with 180 minus 100, or 80 degrees for arc JF. Pretty simple. Okay? Alright, moving on. Notice here you have two inscribed angles. We have several inscribed angles, but two that we're going to look at specifically. You have this angle here, MON, okay, and then you have its partner angle here, MLN. But notice the interesting thing about these particular inscribed angles is that the intercepted angle for MON is MN, 62 degrees. And it makes sense. It's logical, right? Because this is 31. 2 times 31 is 62, or 62 divided by 2 is 31. But if you look here at MLN again, the intercepted angle again is the same one. It's 62. So its angle measure, MLN, is 31, or half of 62. So the conjecture you can make is that two inscribed angles to the same arc are going to be congruent. So two inscribed angles to the same arc are going to be congruent. Okay. And our last two examples. If we're talking about an inscribed polygon, inscribed polygon, that means all the vertices are on the circle. So here's our definition, inscribed polygon. So that's this over here, AB, quadrilateral ABCD. All of the vertices are on the circle. Okay? If you have an inscribed polygon, you would say that that circle is circumscribed. Okay? Circumscribed simply indicates that the circle that contains all the vertices. So this circle right here would be said to be circumscribed because it contains a circle that contains all the vertices. So you have the inscribed polygon, which is on the inside. Circumscribed means it's the circle around or containing all the vertices. Now what's interesting is, if you look at this here, look at this angle measure. We'll get a different color so it's a little easier to see. Look at this angle right here, DAB. What arc is that intercepting? It's intercepting this DCB arc, right? So if DCB or BCD arc BCD is 197, you divide that by 2, and you get approximately 99 degrees. Okay, and we approximated here for a purpose that you're going to see in a second. Okay, so this is actually 98.5, but for purposes we're looking at, it's 99. Okay, if you look on the other side, so let me erase all this. You look at the other side, if you look at this angle, DCB, or angle C, its intercepted angle, or arc, is arc DAB, and it's 163. And you take 163 and divide it by 2, and you get approximately 81. Okay, or it's 81.5. But what can you tell me about these two angles? This angle here and this angle here. Hopefully some of you realize that when you add them together, 99 plus 81, they are supplementary. They equal 180 degrees. Doesn't that make sense? Because the entire circle, let me erase this so we can see it a little bit better. Half the circle is inscribed here, or I'm sorry, is intercepted by angle A. The other half of the circle, DAB, is intercepted by angle C. So the entire circle, 360 degrees, is an intercepted angle. So half of 360 degrees is going to make 180 degrees, right? So that's only logical. Now what you're also going to be able to conjecture is that since this is a quadrilateral, angles D and B are also going to be supplementary. So if angle B is 86, then what's supplementary to 86 would be the 94. Okay, and again, if that's confusing to you on this video graphic or whatever, then please make sure you come see me in tutoring, write this down, or ask me in class. Okay, let's look over this inscribed polygon. Here we have a triangle. What do you notice about angle U? Okay, is that a central or inscribed angle? Well, Inscribed because its vertice is on this circle and its chords, its angle legs make up the chord, right? Well, look at the intercepted angle. So you're going to go from essentially here to V, right? So the intercepted angle is this. What do you notice about that intercepted angle? Especially with this polygon, or this rectangle, or triangle, excuse me. You notice that it's 180 degrees. This is a semicircle. And so what you're seeing is if this is 180 degrees, because it's a semicircle, that means that angle U must be a right angle. So, with that being said, an inscribed angle to a diameter is always a right angle. So here's my inscribed angle U to a diameter, right? Because of the triangle, because we created this polygon, or this triangle. If you have an inscribed angle to a diameter, okay, it's always going to be 180 degrees, which makes sense, right? Because it's the longest side. It's always going to be a right angle, right? And so it's 180 degrees. 180 degrees divided by 2 gives you that right angle. Okay, and that makes sense, right? And you can see that clearly. That's pretty easy to catch on visually. All right, and that's pretty much it. If you have any questions, again, please come see me in tutoring in the morning, past, whatever you need, and we will get it all worked out for you. All right, have a great day.